Look at those giant, trusting eyes. It is incredibly easy to mistake the slow loris for a harmless, cuddly forest creature. But beneath that soft exterior hides a chemical defense capable of inducing intense pain, rotting flesh, and lethal anaphylactic shock. These animals are nocturnal primates, surviving primarily on a diet of fruit, sap, and insects. Their evolutionary lineage is ancient, having split from other primates roughly 70 million years ago, a time when T-Rex still roamed. To survive that long, they perfected a very specific art of movement. By navigating the canopy with excruciating, deliberate slowness, they evade predators tracking motion, silently creeping up on unsuspecting bugs in the dark. But staying still is not their only defense. Out of the thousands of mammal species on Earth, only 6 are known to use venom. The slow loris is the only primate on that list. It is a striking contradiction. A tiny, slow-motion primate that spends its nights chewing on tree sap and catching insects has developed one of the most complex biological weapons in the animal kingdom. This defense is a rare binary system, meaning it requires the combination of 2 completely separate biological secretions that are harmless on their own, but highly toxic when mixed. The process begins with a specialized oil secreted from the brachial gland, a small, dark patch located right on the inside of the animal's elbow. When threatened, the loris raises its arms over its head to lick the area, combining the brachial oil with saliva to trigger a chemical reaction. Analysis of the venom's chemical structure reveals a protein closely resembling fel-D1, the primary allergen in domestic cats. At a molecular level, this specific sequence is designed to trigger an extreme immune response, leading to rapid tissue death and systemic anaphylaxis. Observations of lorises in the wild suggest this weapon is not used for hunting. They are already capable of subduing birds, lizards, and large insects using only their powerful jaws and sharp teeth. Furthermore, unlike other venomous mammals, they have never been seen using toxins to paralyze or cache their meals for later. Defensive uses offer a partial explanation. Mothers will occasionally coat their offspring in the toxic mixture to kill parasites on contact, and the pungent scent of the activated venom is known to repel predators like sun bears and civets. However, producing complex toxins is metabolically expensive. While deterring bears and lice is beneficial, it doesn't fully account for the development of a necrotizing binary system. This level of lethality points to a much more immediate, violent threat. That threat comes from other slow lorises. These primates are intensely territorial, and they deploy their venom primarily against each other during brutal disputes over their home ranges. Field data confirms the frequency of these battles. Between 20% and 60% of observed wild males carry severe necrotic bite wounds, which often result in the loss of ears, fingers, or toes. This internal warfare explains why they raise their arms when threatened. By shielding their face and neck with their forearms, they protect their most vulnerable areas from the lethal bites of a competitor. But the loris's survival strategy goes even deeper. Millions of years ago, changing climates across Asia caused dense tropical forests to recede, replacing them with sparse savanna. This forced lorises to travel across dangerous, open ground. To survive this transition, they adopted Mullerian mimicry, a strategy where one dangerous species evolves to look and act like another deadly predator to ward off shared threats. The loris began imitating the spectacled cobra. It adopted a raspy defensive hiss and a swaying serpentine movement and facial markings that mimic the cobra's distinct eye spots and dark dorsal stripe. By combining a lethal chemical payload with the physiological disguise of a deadly reptile, the slow loris evolved into a highly specialized survivor capable of navigating some of the most competitive environments on Earth. Yet, despite millions of years of fierce evolutionary refinement, modern humanity tends to see only a harmless, adorable toy. This perception fuels a relentless demand in the illegal exotic pet trade, where thousands of wild lorises are poached from the forest to satisfy a global market for cute companions. Because their venom makes them dangerous to handle, poachers resort to clipping or pulling out the animal's front teeth with pliers before they are sold. This modification is a death sentence. Without their tooth comb, these primates lose their delivery system for venom. They cannot groom off parasites, and they can no longer scrape the tree bark they need to find food in the wild. The exact traits that allowed the slow loris to survive apex predators and rival combatants for millions of years have proven to be entirely useless against human commodification. Protecting this species requires us to move past our anthropomorphic obsession with cute. If the slow loris is to survive, we must respect it for the complex, fiercely independent survivor it was evolved to be.